Hello and welcome to IP lesson. In this lesson we will take an introduction to layer 3. Let's start with routing. Routing is a process happen on layer 3 and it's a process of selecting a path to a destination. For layer 2 we cannot have more than one path to a destination, and if we have more than one path it will be blocked by something called STP, Spanning Tree Protocol, and we will learn about spanning tree at this course. But for layer 3 we can have more than one path to a destination, and the routing process will select the best path to our destination. So in our topology here we have this bottom path and we have this top path. The routing process will choose what is the best path in order to reach a destination. Any device will have an IP address, we will call it host. Data on network layer we call it packet. We spoke about layer 2 and we said we have the MAC address table for layer 2, but for layer 3 we have something called routing table. At layer 2 we have the MAC address, but for layer 3 we have the IP address. IP stands for Internet Protocol, and we have Internet Protocol version 4 and Internet Protocol version 6. So when I start to learn about IP address, I had a question. Why do we need the IP address since we have the MAC address? Why the forwarding isn't based on MAC address only? Why do we need the IP address? Let's take a look at this network in order to understand why do we need the IP address. Let's imagine that we have PC1 located on LAN 1 and we have PC2 located on LAN 2. LAN 1 and LAN 2 are connected through the WAN network. So if PC1 want to send data to PC2, and imagine that this forwarding will be based on the MAC address only. In that case, the MAC address table on our switch in LAN 1 will have at least 4 billion MAC address. The reason of that because our switch will learn about the MAC addresses connected to the WAN network, and the WAN network doesn't connect two LANs only, it connects a lot of LANs. So in order to find the destination MAC address, it will take very long time for our switch to do that. You can also think about the flooding. If we don't know how to reach a MAC address and we flood data to all the devices, you can think how bad it will be. Also, flooding will add a security vulnerability. So with the flooding process, we can learn and send data to any device connected to a network. During our learning at the network layer, we will see that layer 3 is avoiding a lot of problems that can be caused if we are using just layer 2 for forwarding. So let's take a look at IPv4 header. In IPv4 header, we have version, length, DS field, packet length, identification, flags, fragment offset, time to live, protocol, header checksum, source IP address, and destination IP address. Source IP address will be the IP address of the sender. Destination IP address will be the IP address of the recipient, similar to the MAC address. So let's see what is those fields mean at the IPv4 header. Version refer to the version of IP. Is it IPv4 or IPv6? Packet length define the entire packet size, and this means the data, the layer above the network layer, plus the network layer itself. We have also identification. Identification identify the group of fragments of a single IP datagram. We will speak about the fragmentation in the next slide. Flag define if the data should be fragment or not. We have also the fragment offset. Fragment offset used to indicate the starting position of the data in the fragment in relation to start of data in the original packet. Time to live or TTL, amount of hops that a packet set to exit inside the network before being discarded by a router. The default TTL for Cisco routers is 255. Protocol defines the type of protocol in transport layer. So it defines if it's TCP or UDP. Header checksum is used for error detection. So a lot of fields on IB version 4 is talking about fragment. So what is fragmentation? We spoke already about the segmentation, and we said if we have a data and we need to send this data to a device and this data size cannot be sent in one time, what will happen in transport layer is that we will cut the data to pieces and each piece will call the segment. So same thing here will happen in network layer also. So you can ask a question, why do we do segmentation and then we do fragmentation? Shouldn't it be only the segmentation? And to answer this question, we should know first that there is some technologies and some protocols add a lot of headers to the data in network layer, which cause that the size of the data will be bigger than MTU, maximum transmission unit, and in that case we will need to do a fragmentation in network layer. One of the technologies that cause the fragmentation is a technology called VPN, Virtual Private Network. VPN is used to transmit the data securely through the WAN, so it does some encryption and hashing, and that can cause that the network layer size will be bigger than the MTU size. In that case, we will do fragmentation. So flag will define if the data need to be fragment or not. Identification will identify the group of fragment. Let's say fragment 3 belong to which group. The next thing that we need to take a look at it in details is TTL. TTL stands for time to live, and TTL is used to prevent any loop in the network. So by default, any device will send data. The data will have a value of TTL, for example 255 at network layer. Every hop the data will take will reduce the TTL by 1. So here the data exit out by 255, then 254, 253, 252, 251. By default, Cisco assigned 255 for the TTL and Windows machine use 128 for TTL. So what about if we have a network that is more than 255 hubs away? In that case, this network will be unreachable. So TTL reduce the loop in the network. TTL also add security to our network by proceeding only the fresh data. Also, TTL will reduce the latency in our network by discarding the unimportant data. So let's take a look at our topology when we add the routing and the IP address details. Here we have 5.5.5.0/24. This refers to the network address /subnet for that link, the link between the router and the PC. One here refers to the IP address of that device, which is the PC. So the PC will have the IP address 5.5.5.1. G1 refer to interface Gigabit Ethernet 1, which is our router interface, and we have 3 here. 3 here refer to the IP address of interface G1 on the router, which is 5.5.5.3. Same thing here, we have 4.4.4.0/24. This interface on the router have the IP address 4.4.4.3. This PC have the IP address 4.4.4.2. Most of the forwarding in the network will be based on the IP version 4 or IP version 6. So let's start with IP version 4. IP version 4 is written in 32 bits or 4 bytes. The IP version 4 is written in decimal format. For example, 1.1.1.1. Each byte separated by dot. We can see the IP version 4 in the routing table. You can also open the CMD and enter the command route print. This will show you the routing table on your Windows machine. The IP address is unlike the MAC address. We spoke before about the MAC address, and we said that any device, any interface comes with the MAC address burned on it. That's why we call it BIA or burned in address. The IP address, we have to type it by ourselves. We can assign it manually or through a protocol called DHCP. The downside of the IP address version 4 is that the IP address is about to exhausted. So right now we have a very limited IP address version 4. That's why a lot of people start to use the IP version 6. So how our device will learn and communicate with the IP address. We spoke already about the MAC address and we spoke about the flooding. So if our switch receive a frame and this frame destination was unknown, our switch will forward this data to all the interfaces except the one it came from. Similar to our example here, our switch received data with unknown destination from interface FA 0/1 Fast Ethernet 0/1. It did a flooding and forwarded the data to all the interfaces that he have. Interface Fast Ethernet 0/3 and 0/2 in order to learn about the MAC addresses. Layer 3 doesn't do the flooding. Any packet will arrive to our router and this packet will have unknown destination will be discarded, and the router will not forward it to anywhere. So first, for the IP address, we have to assign the IP address manually or statically through the DHCP protocol. After we assign the IP address to the interfaces, we have to add the routing to our device. The routing can be assigned statically. We can type it by ourselves, or it can be assigned by the routing protocols. Let's take a look at our example to understand more how is the layer 3 forwarding work. Here in our example, we have two PCs, PC1 and PC2. We have router 1, router 2, and router 3 between the two PCs. We have network 1.1.1/0. We have network 1.1.1.0 between R1 and PC1, and we have network 2.2.2.0 between R1 and R2. We have network 3.3.3.0 between R2 and R3, and we have network 4.4.4.0 between router 3 and PC2. So we have to put the IP addresses manually or through the DHCP protocol for all the interfaces that we have here through that path. After that, we have to either type the routing command statically or enable a routing protocol. So after we did that, PC1 want to send data to PC2 because our PC doesn't do routing. It just knows about the gateway. The gateway for PC1 will be interface G1 on R1. So any communication our PC wanted to do, he will send it to interface G1. Our router supports the routing and he know multiple destination. So the router will look at the routing table. In the routing table, it will find the network, which is 4.4.0, and the interface that our router can use to forward the data exists in the next hub. The next hub, 2.2.2.2, is R2 interface G1. When G1 receives this message, we'll look at the routing table and look for the next hub for the destination network, which will be interface G1 on R3. R3 will find out that the network 4.4.4.0 is directly connected and will forward the data to PC2. As you can see here, the forwarding at layer 3 is totally different than layer 2 forwarding. This is the end for this lesson. Thanks for watching and see you in the next one.